going to be all about proportions. The materials you're going to need is your spiral notebook. Any old calculator would do, even if it's just out of a cereal box. We just need the basic buttons. And a ruler. Now, the ruler is optional only if you're very neat in your notebook and in your work and you really want to make sure your shapes are exactly right. You'll need a ruler. Otherwise, you can eyeball it like I do. All right, vocabulary you're going to need. There's 4 words here. Unit means 1. If you are working in a factory, you would have 1 unit. You would have a unit. It means you have 1 unit. You have 1 case of something. Equivalent. You see the word equal in there? Similar and congruent, you should be familiar with. Similar means same shape. So if you had a right triangle in figure 1, it would be a right triangle in figure 2, but maybe a little bit bigger, a little bit smaller. Congruent, on the other hand, you would have a right triangle in both figure 1 and figure 2, and it would be the exact same size. So this is same shape, this is same shape, and same size. All right, let's go ahead and solve some proportions together. The first kind of question that you're going to come across is, are they proportional? And here's where you're looking at 2 fractions and you're trying to decide, do they go together? Are they proportionally bigger or proportionally smaller? Another word for that would be an equivalent ratio, an equivalent fraction. You remember doing that in the fraction unit? So if you have 2/7 and you're looking at that in comparison to 6/21, there's a couple of things you can do. First, you can look side to side. Remember when we did our fraction unit, whatever you do to the top, you do to the bottom? If it is a common factor, 2 times 3 and 7 times 3, then you know it's proportional, okay? But it has to be whatever you do to the top, you do to the bottom. So these 2 fractions are proportional because you're multiplying by the same exact factor. So yes, it's proportional. Now sometimes you have fractions that don't work together nicely. They're not in the same normal multiplication tables that we know in our head, so we have to do a little bit harder thinking. They might not be in the exact same fact family, and we're trying to figure out, gosh, are they proportional or not? Is that fraction being increased or reduced equivalent, the numerator and the denominator? It might not have a factor. 6 and 8. You can't get from 8 to 6 in any kind of fact family. So there's another route you can go. If you have numbers that are a little unfriendly, what you can do is use cross products. And I think you remember being taught the butterfly method. That's what this is. The butterfly method is when you take the 2 numbers that are diagonal from each other and multiply them. So here you're going to multiply 24 and 6 together, and you're going to multiply 8 and 20 together, and you're going to look at those 2 products. If the 2 products are equal, then yes, it's proportional. If they're not equal, as in this case, it is not proportional. All right, so you have 2 methods. First, you can look side to side. That's a nice, easy one. Quick and easy when you have numbers that are friendly. If you have numbers that are not friendly, then you can use cross products to help you figure that out. All right, go ahead and pause the video and see if you can go ahead and work out 3 and 4. Try them on your own. Don't peek, don't cheat. Try them on your own first. Use your calculator, and then come on back and I'll go over them with you. All right, so hopefully you've done these on your own. Now notice 2 to 4, these are nice friendly numbers. If I go from 2 to 4, I'm multiplying by 2. Okay, that's same fact family. Let's look at the denominator. I'm not multiplying by 2, am I? I'm multiplying by 3. I'm multiplying by 3. So because they're not the same factor, top and bottom, I'm going to have to answer no. Now, if you weren't sure and you wanted to use the cross product method on this problem, you certainly could. It would be 2 times 9 and 3 times 4. 2 times 9 is 18. 3 times 4 is 12. You can see that those products are not the same, so my answer is still no. It doesn't matter which method you use. All right, for this one, example 4, those numbers are not very friendly, are they? No, instead, we're going to use cross products. So we're going to put the 18 and the 10 together. You get 180. You're going to put the 12 and the 15 together. And let's see, I got 180. So, yes, they are proportional. All right, we're going to do some more practice problems with that in class. All right, check out this kind of problem. Here we have a proportion already set up, but we have a missing number. All right, take a look at number 5 here. Go ahead and copy it down. What we're doing is we're multiplying the numbers that are diagonal, and we're solving using an equation. So we're still using the cross product or butterfly method, but we're going to use our equation information as well. So here we have our proportion already set up. There is an equal sign hiding under there. They are telling us that they're equal. We have to figure out what this missing number is. So we're going to start with, okay, these two go together, that's x times 3. And these two go together, that's 6 times 10. Now 6 times 10 is obvious, but please remember that x times 3 is the same as 3x, right? And then we solve just like we would an equation. The opposite of timesing by 3 is dividing by 3, so our missing number must be 20 in order for this to be a proportion. So you're using cross products, and then you're solving using algebra. Go ahead and try 6 and 7 on your own, and come on back. If you're confused, watch me do number 6, and then pause the video and try number 7 on your own. Try to be as independent as you can. All right, number 6. If you look, do you see these two numbers are diagonal? And they're there? So we're going to do 39 times 12. 4 times x is on the other side. Okay? 39 times 12, if you type that into your calculator, you get 468. And 4 times x is 4x. Put an equal sign in between there and solve it just like you would an equation. Divide by 4, right? Because that's the opposite of timesing by 4. So we get, let's see, 117. All right, if you haven't tried this one on your own yet, pause the video and give it a shot, all on your own. Otherwise, I'm going to go ahead and go over number 7. These two go together. 5.5 times m is 5.5m. And 6 times 16.5 is 99. The opposite of timesing by 5.5 is dividing by 5.5. And the m would equal 18. Don't be afraid of those decimals. You solve them just like you would whole numbers. All right? That's the basics of proportions. And if you can do that, you can do any problems. But here's some extensions. And we're going to do some practice problems with each one of these types. But we've got binomials here. Unit rate, which means 1, similar figures, similars that same shape, just different size, and then scale factor. So I'm going to go through these with you and know that we're going to do more of these in class. Okay? Binomials, they look kind of tricky, don't they? But they're exactly the same format. 8 times 14, which, let me see here, 8 times 14 is 112. And, whoops, I kind of put that on the wrong side, didn't I? Let me fix that. I should be doing this one first. 4 times x minus 3. It doesn't really matter except when you get into higher level math, so you better do it right from the beginning. So 4 times this expression and 8 times 14. What's really important is those parentheses. A lot of people forget the parentheses and they just put 4x minus 3. That's not the same thing. You have to multiply the 4 times the entire expression. So we have to do some distribution. Watch those negatives. 8 times 14, 112. All right? Solve using your algebra. Plus 12, right? And then the opposite of timesing by 4, dividing by 4, and you get x equals 31. All right? The unit rate problem. How much for 1? Well, if it's 36 miles in 4 hours, notice my labels. Super important that you put those labels in because you want them to match. We want to know how many miles for 1 hour. Did you hear what I just said? 1 hour. So where do you think you would put the 1? Labels have to match. You have to put it at the bottom. Hours, hours. Make sure they match side to side. You solve just like we've been doing. 36 times 1 and 4 times x. Opposite of timesing by 4 is dividing by 4, and x equals 9. So you would go 9 miles in 1 hour. All right? Similar figures. You're going to take a look at these two figures and find corresponding parts. Again, we're going to do more of this in class. 8 goes with 24. So I'm going to put small and large as my two labels. I've got a small triangle and a large triangle. The 8 from the small triangle matches up with the 24 from the large triangle. Okay? Corresponding parts. The 7 would match up with the x, because they're both in the bottom of the triangle. So again, the small triangle has the 7, the x is in the large triangle. All right, we would solve it just like we've been doing, cross products between these two and cross products between these two. 8 times x and 24 times 7. Did you type it in? Divide by 8, because that's the opposite of timesing. Solve it with your equation work. And x equals 21. And the last one here is scale factor. The distance between Durham and Richmond is 10.5. All right? What is the actual distance if on the map? You know, when you look at a map, they have a little scale in the corner. That's super important when you're reading a map. And I know GPS these days kind of takes maps out of the equation, but you really should have a general idea of where you're going in the world, because sometimes the GPS fails, or sometimes it's not up to date, and you're suddenly on a dead-end road and you don't know how to get out of where you're at. So try to get used to looking at a map, even though we have GPS availability. All right, so we've got, notice it says centimeters and miles. Those are the two things that we're going to write in our proportion. Centimeters and miles. And it really doesn't matter which one you put on top and which one you put on the bottom. That's kind of messy, isn't it? Let's try that again. Centimeters and miles. I'm going to choose centimeters at the top, but it really doesn't matter, as long as you keep your numbers lined up. This says 3 centimeters for every 80 miles. Okay? Well, if you actually measure it on the map and it's 10.5 centimeters, where do you think you would put the 10.5? Make sure you match up the labels. The 10.5 would go up here, because that's where I'm putting my centimeter numbers. All right, this is our missing value. Multiply the two numbers that are diagonal. And we've got 80 times 10.5. And let's see. Type it into your calculator. 840. The opposite of timesing by 3 is dividing by 3. So I have 280 miles to get to Richmond from Durham. All right, I'm going to see you in class. We're going to do some more problems. See you soon.